The database which we discussed is this database, and it is open source and now reaching version 3 or 3.01 as the latest. And the last time I saw it was 3. And so that's the database that he used on the back end. Express is the framework to render pages on the client side. And AngularJS is a 50 kilobyte library. Angular. And the library is open source. And what this does is gives you bidirectional data binding between client side and server side.
One more time on that one.
So bidirectional data binding between these guys, meaning you can refer to. Let me give you a simple example to comprehend this simply. Let's say in you create an entry for the user. So the user is sitting here, and they are typing something in some name and address fields. They're typing some detail. Now you want to transmit these details back to the server and store them. And that handling, if have you written code to deal with such a input field, create an input field and capture input from the user? If you do such things, Angular will give you very simple programmatic constructs to write those things without worrying too much about the back end.
So is it taking advantage of like XML HTTP request or something like that?
Yes, exactly. So they go beyond that in terms of they give you. So there are, if you look at JavaScript frameworks. In JavaScript frameworks, and if you compare them and contrast them, there are so many of them. You would be. It is actually mind blowing. Let's see how many of them are.
Right.
It goes on and on. It's never-ending list with comparisons of features and this and that. It's mind-boggling. You don't know which one to use.
So what components we're looking at now?
So we were specifically focusing on the mean stack.
Yep.
And the architecture. We'll discuss more specifically, and Dinesh will come and describe what he has done with it. We're just beginning to discuss briefly what he has chosen as components to build his architecture for that website, for the service that he has produced.
Since it's kind of like a lamp, meaning it's has its own adherence, fairly large adherence base that they say this is a good thing.
Yeah, it's a good, very popular to use. People use this pretty much quite a bit. So, so it's conceptually similar to the LAMP stack.
Yeah.
But only in concept.
Is it 100% comparable to the LAMP stack?
Not at all. Not at all. Not at all.
Okay.
No. It's only in concept. The idea here is that it removes and reduces the developer burden in writing code quite a bit. So you don't have to write too much code because Angular will do it for you. Like in example of Rails that you saw, yes. In Rails you saw we got ready-made code developed for us when we constructed a controller. If you remember that. We programmatically wrote code with Rails. So it helped us write code, and we were able to create a simple application to show the current time and publish it on Heroku.
Well, let me ask a question. So I'm tracking with you, but LAMP and mean both have the same goals from the perspective of developing an application, all the parts and pieces? Okay.
Yes.
All right.
Except in LAMP, the language is PHP.
Yeah.
And in here, the language is JavaScript.
Yeah, Java.
And the beauty of this mean stack is that you write code for the front end as well as the back end, all in JavaScript,
Yeah.
like absolutely all. Because this node section is also JavaScript, which is running on the back end. Angular, which runs on the front end is also JavaScript. Express is the web framework, which is a application server, is also JavaScript.
Yeah.
Mongo database queries are also JavaScript. And so the whole thing is entirely JavaScript. If you know one language, you can do the whole program from the back end to the database all the way to front end design. Whereas in PHP, PHP runs only on the backside. You still have to worry about the front end look and feel and styling, and you still need to do JavaScript. Any function on the client side, you still have to worry about. Even though you know PHP, you still have to deal with, on the client side, still have to have JavaScript. And same is with Rails. So if you write Rails programs, on the back end, you will write Ruby, but still on the front end, you will have to have you have to use JavaScript. It's a necessary evil. JavaScript is a necessary evil. You cannot get away from it. And as I said the last time, JavaScript is so big that it runs about just about any machine you see here.
Kind of like VI.
Kind of like VI. And it is so big that there is a very good book written on it.
Yeah.
It's called JavaScript, The Good Parts, and that book is very small.
Or there's JavaScript, there's all kinds of massive terms.
Right, the good parts. And it's a really small book.
That's right.
Yes. So that was about mean architecture in brief, and we'll have this guy talk to us about what he has developed in his app, which is, where is his app? Here. So here you can basically sign in, sign up, and say, if I want to go to Puerto Vallarta, there are no results found for Puerto Vallarta because he is not supporting yet. He supports only Seattle, New York, and certain cities. So it's a new startup. Puerto Vallarta is not included. But let's say if you go to Seattle, search.
You didn't swim.
Huh?
You didn't go in the ocean.
I did.
For how long? Okay.
Okay. Yeah.
Just don't cross the ocean.
So the idea, as you noticed here, some of the helpful things that you will notice if I type New York, and see this is drop down that comes up. Yeah, so Angular helps you in doing such things automatically. It will go to the back end, pull up the database, look for all the cities that contain the letter N, as in November, which is what I typed.
Yeah, that was always a pain in the.
Yeah, and it is quick. If you just type the letter Y as in yellow, or A as in apple, whatever you type, it just quickly populates and shows you, and it is going to the backside and drags a collection containing all the things you need. It contains that letter N as in November.
Yeah, without having to refresh the page, just does that.
Yeah, exactly. And looks up Mongo on the back end, pulls up the short subset, and creates a drop down and populates it. You can just quickly go, okay, I want to go Big Island, boom, and here it is.
I noticed the licenses, just a ton of them are from, this is from MIT. And then MIT's put jQuery or Dory. You got nothing else to do there? What's
The licenses?
Yeah, I mean, they're all from MIT, or a lot of them for the frameworks, the JavaScript.
Hey, MIT is one of the most liberal licenses that you can think of, which is nice to use. MIT license is like this.
Well, I know, but even just the number of frameworks you're talking about, the proliferation of frameworks, a lot of them are coming from MIT.
No, they're not necessarily coming from MIT. This is the MIT license for Cloud Genius. So it is not coming from MIT, it's the MIT license. This is the language, the body. These 3 paragraphs are the MIT license language. It is not coming from MIT. I am using this language, and it is generally called the MIT license. It is very liberal.
Yeah, you can do everything you want with it, and by the way.
Exactly. That's why I chose this, yeah. So the trusty virtual machine is given under this license. So when you click through the import button, that's the license that you see that pops up when you have to agree and sign in blood.
So when you get
There is no guarantee.
you get your Google car, your self-driving car, and then you get the MIT license,
Does it-
don't do it, or
That's why I did not buy a Google car.
Reliable.
with the MIT license.
Okay, got it.
Okay, so similar to MIT license, there are many other licenses. In fact, one of the funniest licenses I saw was from, what was that called? MPICH license. MPICH. Yeah, this license was very funny. I don't know, this is like I'm remembering from long time ago. And let's see where the license is. I think this is the MPI standard that I used the first time in 2005 in a Microsoft product. And the license was, here is the code, use it. I mean, that's it. There's nothing much written about how you use it or anything like that. So we had to go back to them. This is Argonne National Laboratory, which is this agency. We had to use their code. And so we had to go and explicitly ask them an email permission to use their code. And this is Argonne ANL. If you know this laboratory, it's anl.gov. It's a big name. Not many people know about it, but it's a government lab doing mathematics and computer science research.
Was it ANI?
ANL, Argonne National Lab. So the thing that I want to discuss now is when we start talking about this word, architecture, what do people really mean? And where do people come from? And when we think about organizations of large size, like Boeing, for example, how do you define what is a good architecture? And who makes that decision as to what is actually needed from for a given project? How do you go about designing, defining those things? So I would like to bring up a slide deck, and I rarely use a slide deck, as you have seen, but today I am going to bring one up to illustrate a nice graphic that I have there. So I'm heading there, and I'm going to say that this is the chart I will be using to discuss.
So do we have access to this material?
Yes, yes, yes. And if not, I'll point you specific links to where it is.
Now you have a career.
So the idea that I'm going to describe is this concept of what actually shapes the business. Like any business you think about, who are the people, who are the agencies, who are the operators? What are those forces that shape a business? Ultimately, at the end of the day, we are designing some software, designing some architecture, some product, some service. For who? For somebody who's going to use it. And so that somebody, if you think about in this picture, in this 5 little colors, where do you sit in? Like imagine you are, there's nothing to be imagined here. You are, if you put yourself in these 5 buckets, where would you put yourself if you are a Boeing employee? Let me ask you that question. If you're, since you are 3 of you are Boeing employees here, so I'm asking you the question. Where would you fit yourself into these 5 buckets?
It just depends on the day. If I'm at home and I'm having somebody come over to build my fence, I'm the customer.
Correct.
And if I go to work tomorrow, let's see, I could be a supplier, and I'm talking to many customers. depending on who I am. Or I could just represent the company at that point in time, when I'm at work.
Right. So when you're at work and when you are talking to your team members, maybe your boss or maybe your subordinates, and you're doing your day-to-day job, not externally, not interacting with anybody externally, just only within the company. In that context, where would you put yourself in these 5 buckets?
So you could be in any one of them at any time. You're sometimes in the company, sometimes you're a competitor if you're working on a project or somebody else is working on a project.
Yeah.
Right.
So sometimes you're a customer.
Yeah,
because
yeah.
you're
So
using
two,
somebody's product
right.
or-
In IT, I look at myself as a supplier to the business.
Sweet. And I think that's the right way of thinking.
Yeah.
Is that you're providing your services to the employer, and you're essentially supplying your services.
Right.
And it is no different than somebody like him, who's an outside consultant, providing services to a customer, and that's a supplier. They're selling something, selling services. I'm a supplier to you. I'm selling educational services, and you are buying it from me. I mean, your company is buying it from you. Yeah. So think about it that way. Somebody's buying. So the idea is to understand what your role is at a given point in time, very clearly, very, very methodically, like you already do, which is awesome. Now, imagine another case when you have, let's say, think about Dell and HP. Are these 2 companies competitors?
Yeah.
Sometimes.
Or are they complementors?
Sometimes.
Sometimes they're that.
So when are they when? When are they what?
Well, they're always suppliers.
They're always suppliers
customers,
to,
Always suppliers. Sometimes competitors, depending on if they have the same technology that we want to go after.
right? So you have a Dell laptop that Boeing will buy, or a HP laptop that
Yes.
Boeing might buy. They're competitors. Beautiful. But when would they become friends? Like really, really friends, and go out and party, and literally, I have seen this happen. Dell and HP people really go hand in hand together and fight together with the opponent.
I mean, I can't.
Where is that?
I can't really say in Dell and HP, but let's say Dell is providing the servers and HP is providing the software on top of those, and they're gonna work together on providing something. Okay, I mean, it's when they collaborate together.
Right.
Storage.
Yep, storage. So anywhere it is not directly head-on, then they tend to cooperate, right? When you move it like this, they tend to cooperate. When you're directly head-on, they fight, and it's totally natural. I have seen, companies, very specifically HP and Dell, going really friendly and fighting together against Microsoft,
True, yeah.
fighting against Intel to bring the price of the CPU down, to bring the price of the Windows OS, Windows Server OS down. And Dell and HP and, you name it, everybody else together that make machines and get licenses of Windows from Microsoft will party together, cooperate so much and put so much pressure on Microsoft to bring the price of the OS down, annual license price that they have to pay, so that they can remain competitive compared to Apple machines. At least they think they are, whatever. And so that I've seen that many times. So the companies can change from being competitors to complementors anytime, maybe multiple times, and multiple number of shifts in the role every day. And there is a word for that. If you have not,
Samsung would be a good example of that too.
yes,
They're
yes.
constantly fighting with the integration of components.
That's right. With Apple all the time. And so there is this word for it, and I'm going to write it because I cannot say it properly. I may have said it before. Have you seen this word before?
No. Co-opetition?
Co-opetition. There is a book by this name, by Barry Nailbuff and Adam Brandenburger. You should read that book.
Cooperation and competition.
Yes.
Co-opetition.
Yeah, you Google it. Wikipedia.
Yes. So co-opetition. Here's the book. And this book is actually pretty darn good book. I love it. It is available on Amazon. And I purchased this book in 2001. And this was the purchase order. And that's an awesome book by Adam Brandenburger and Barry Nailbuff. They are from Yale and Harvard, two professors. And this book is the title. And the title is very obvious now that I have described it. Right? It means that you basically switch between your function whenever you feel like. You know, you sometimes are competitors, sometimes you're competitors, and you do it all the time. So that is something to think about when you, by the way, this chart comes from the book. This concept comes from that book.
So you're talking about, if I were to look at the analogy of trying to get Microsoft out of the front seat and demanding, economic price, you're talking about HP and Dell and all of the big hardware competitors also contributing to open source in many ways so that the prices are driven down.
Yes, yes. Yeah, you can use any kind of force, any tactic to play a game. So this is basically game theory. If you heard of the word game theory. Heard of it? The idea is businesses play games. And I'm not talking about game as in the case of cricket or tennis or basketball, but business games. And game theory applies in those contexts. And there is another good book on this topic by another professor that you should read, and it's called Games Businesses Play. And it's by Pankaj Ghemawat. And that book is also very good. And it's a business book, but it helps you understand, if you're dealing with a business, as to what forces can be in play when you're playing a game with another company. The name itself is Games Businesses Play by Pankaj Ghemawat. And the underlying idea is that you sometimes, in certain situations, you can pay and play. Or sometimes you can get paid to not play. You heard me that, right? Sometimes you can get paid to not play.
Right.
And so that's the kind of game I'm talking about. In cases where Nintendo, long ago, if I remember the exact context, I'll describe, but Nintendo was about to release a product in the market in competition with Sega, and Nintendo chose not to introduce the product, in turn got money from Sega and kept the money for not introducing a product. And that's okay, apparently. And so that's the game theory in play, where you can still make profit by not producing a product.
Yeah. Wow.
It can be anti-competitive in this country, but apparently they have done it in other countries by not introducing their products, by not playing, but still making money. Strange, but possible. So there are laws in this country that do not allow certain behavior. So that did not happen in this country, but in other countries it has happened. It is totally appropriate. It's a strategy where you chose not to go in that direction, and in return, somebody compensates you. When you're applying this logic to this country, read the law. Read the law first, before you apply this concept. I think there are laws against collusion, there are laws against price gouging, signaling, and so you should read those before you apply those things in this context. Very careful if you're in that game. But books are books, and they can talk about situations that do not apply to this country, and so in the books you will see these examples. The reason I bring up this topic essentially is to help you understand that these are the fundamental forces that shape any business. And if you connect these 5 items together in form of a net, you can see that Boeing is the center blue oval, is a company, and they have these customers like Emirates Airlines in the red. And then on top of Emirates is Nilesh, who might fly Dubai, and that can become a customer. So if you keep building this chain, it becomes a huge network of entities that are doing business transactions. So think about this as a building block of a network, and that concept is defined in the book that I mentioned as value net. So the book authors, Adam and Barry, describe this concept of value net as a network of players in the industry that play together, that compete, that cooperate, that supply, that get supplied to, that produce things in collaboration with other entities to produce value and to capture value. The value net, the idea is to create something useful and to get paid for it. Now, having described this concept as a fundamental discussion block, I will switch topics into how this applies to IT. Now, in the red item that we had here, which is the customers. Customers are getting a product, a service provided to by the company. And so they expect certain types of software that are needed to serve them properly. And these are some list of examples of types of software applications that IT departments typically will have to take care of customers, meaning the red bubble, these ones. And so if you look at this list, you will have software to deal with sales management, shipping, logistics, return, and the list goes on. Then anything that interfaces with the customer, you can compile them, collect them in terms of applications that you probably have already in your companies, where you're using some form of some software somewhere along the line to service your red bubble, which is your customer. I may be missing many things here that you might have, but this is just an illustrative list. This is how you look at when you're dealing with the red item on top. This is an entity that you need to worry about. I think the most important entity, which is the customer. And you need to provide services internally in the IT to service the customer's needs so that they can buy from you, they can understand what you have, they can get, they can pay you. If something goes wrong, they can return, make corrections, get services, all these things. You need to have tools and services in place to make these things happen. Let's switch the bubble to another color. What do competitors need, or rather, what do you need from competitors, is the key to understand what would be another company like Airbus Industrie may be doing. Airbus, your competitor, Boeing's competitor. Airbus. What would Airbus be doing? Boeing needs to know. And so there is this aspect of understanding competitive intelligence, which also has a suite of software available in the industry. I don't know what you use exactly, but in many companies, there are competitive intelligence software that people deploy and analyze trends in the ecosystem, in Twitter, in Facebook, LinkedIn, anywhere else you can find bits and pieces of useful information as to what the competition may be doing, or maybe their next move is that you want to extract that information, analyze and make sense out of it and act upon it. to understand the trends that other industry, the competitors in the industry may be taking on, that you may want to react faster than they can to win. And to help you do that, IT can provide technology services to enable and understand competitive intelligence.
They have a initiative called Business Capabilities 2020 in the company now, which is exactly that. And it's about coming up to IT speed for Boeing to compete against Airbus. And
Yep.
all of that.
So I may not have the exact nomenclature, but the idea essentially is to look at the big picture, where the businesses are getting forced from different functions and different entities, how things interoperate. Like customers influence us and we influence customers, and every bubble interfaces with another bubble in some fashion. And the competitive angle is to look at what they're doing, what they may be doing legally, not spying on them, but legally understanding what they may be doing. And in other countries where it is legal to spy, people go to the extent of spying, and they actually send spies and have them employees of the other company also, and get insider information. It's legal in certain countries, not in this. But whatever is legal in whatever land, you exploit to the fullest possible extent permissible by law of the land, and do that. And that is legally valid as long as you're following the law of the country. Not specific to this country, but other countries that do not have certain laws,
Sure.
or they allow certain behavior. And so if they allow, it's okay to do it.
Nice ethics course there.
I mean, it's okay. I'm not saying you go and do it. I'm saying it's okay to do it.
Yes.
Technically legal. If your company policy allows, you can operate in the country. If you happen to be operating in certain country where the law allows, and if you find it's okay, you do it. There's nothing wrong technically or legally in doing that if the law says so. And companies go there and do that. I have seen it, many examples. Large companies, as simple as, where do you put your money? Where do you stash your cash? Simple things. Big companies, even here, do that all the time. Yeah, they do all the time. I mean, is it legal? Absolutely, yes. Now, is it ethical? That's a different question. Now, is it ethical to store American dollars in Europe? I don't know. I'm not going into ethics at all. Is it legal? Absolutely, yes. So the IT implications from the competitive angle. The next angle is the green angle, which is the supplier. And there are tons and tons of enterprise software to deal with suppliers. And you've seen that. You use it already. Some of the examples will be, you probably use this thing called, what is it called? I2 Planner. It used to be called I2 Technologies. It has a new name these days, Managistics Corporation, or supply chain management software from Oracle, or JD Edwards, or some variation of that from either IBM. So you will have some software deployed in your organization to deal with your suppliers so that you get the parts you need to make your airplane. Right? There are other angles involved here, which is this aspect of optimal reorder size, which is a mathematical term. If you remember this, word optimal reorder size, you can calculate it mathematically and identify how much inventory should I buy again and again every week to fulfill and keep my inventory levels of Dove in the store shelf in Walmart. How much Dove soap should be on that shelf every Saturday is calculated mathematically, and Procter & Gamble personally brings it and delivers it to Walmart. Do you know that? That Walmart doesn't go and order. Procter & Gamble personnel come and put it and decorate it on the Walmart shelf. That's the power of Walmart. Do you know what's the most expensive real estate on the planet? Is the Walmart shelf on a per square foot basis. It is very expensive to put your stuff in there. And Walmart has, totally operated on how do you operate their supply chain. Is the best known example is Walmart, and probably now Amazon, because these guys have really refined the art and science of managing suppliers. Walmart doesn't have to do a thing. In fact, P&G will monitor how many Dove soap bars are there on the stock shelf of every Walmart across the globe, and fulfill it and keep that optimal order quantity so that you're neither too short or nor overstocked. And so they will track how many items getting purchased, how many items getting returned back in the store and back in the store shelf, and keep that track for every single week across every single Walmart across the globe.
They're able to plug into Walmart's real-time inventory.
Yes, everything has to be real time. And so you need some IT software. That Walmart is big into IT, just like any big company is. And they will apply these concepts and principles to make it happen for their stores. And you do that also in Boeing, I'm pretty sure. I don't exactly know what you do, but you know it. You do these things. You will gather these data, and you will know what things you need in what is known as just-in-time concept. These are Japanese concepts. This JIT is a Japanese concept you apply all the time. Is to bring inventory of things you need just in time, not a day before, not a day late. If you bring a day before, what happens? You're wasting money on interest, on stuff that you buy beforehand, and it is sitting idle, doing nothing. Idle is waste, as we saw in our initial discussion on the day one of DevOps, when I said wastage or doing nothing is idling is waste, and waste is bad. Any waste is bad. And so here, you bring things from your suppliers just in time, for which you need systems and software in place to make things happen. You also need to maintain relationship with your suppliers so that to not disturb those finely balanced relationships, but keep them in control also at the same time, so that they keep supplying you and do it profitably for them as well, so not to screw them from a business perspective. Next bubble. We have partners. We collaborate with them. So we need to sometimes share a document with them. So we need SharePoint sites that we extend with our partners, and that they can collaborate with us, or some other method, some other software that is used to cooperate between, say, so who would be your partner? An example would be, let me give you an example of what I call a classic complementor. So this word here is the letter E, not I. Okay. I'm saying you're looking good. The word I comes into play, right? I'm not saying that. Not that you don't look good, but I'm saying that the word I'm using is complement, this word. And the example I would give is that if I just had a cup of tea, will coffee be interesting for me? I just had it. Probably not. So these two are kind of substitutes, like competitors, right? But this product called sugar is interesting to both the tea maker and the coffee producer, right? So the sugar is a complementary item to tea, and sugar is also complementary item to coffee, right? So this is a good relationship, complementary relationship, and this relationship is competitive. You see that? So tea, coffee, and sugar. Positive, positive, not so positive. You get that point, right? So this, if you apply to Boeing, who would be not a supplier, but a complementer?
Could be like.
I would say Rolls-Royce.
That's a supplier, right?
Yeah.
Yeah. So not a supplier. Yeah, they give you engines.
Well, they complement. I mean, we build the aircraft, we integrate in the engines.
And they also sell to other, to Airbus.
Right. So my question was very, very specific to this picture. Like, where would you put, what item would you put in the dark blue box? Dark blue bubble on the far end. What would you put? If Boeing is in the center, what would you put in the dark blue? Here.
Well, Dennis and I were saying Rolls-Royce.
But get something else in mind, I'm happy to hear it.
What? One more time.
So if you've got something else in mind, I'm happy to hear it. I mean, it's not exactly the same thing, but.
Yeah. I would say somebody who is helping helping this Emirates Airlines in buying a plane, like a loan company.
Yeah, okay, so GE
GE Capital. Yes. So that company, GE Capital, is a very good example of a complementer. Yeah. Right. They are helping you. They're making your tea sweet.
Yeah.
Right. They're making your coffee sweet.
Their product isn't used, or they're not used in
Right. They're not an input.
part of the product.
Yeah. It's not a supplier,
Yeah.
but it's making your product sweet. And that's a classic complementer. The blue box, the blue oval. And so think in that context always in this framework when you're thinking about a problem that you're trying to have or a product you're trying to sell, that you need to clearly understand who are these bubbles around you. And so GE Capital is one. There may be other banks or other financial institutions helping your customers, making your product a little bit sweeter, like the sugar in tea and sugar in coffee example. That coffee example, sugar example really gets people. Very easy to understand. Everybody understands that, I just had a cup of tea. That means I don't want coffee right now. Maybe tomorrow, not right now. And sugar helps. So in like 15 years ago, Microsoft wanted to be the sugar company.
Yeah.
So that they can partner with HP, partner with Dell.
Yeah.
Yes.
Yeah, even Apple.
Yes. And so that was the exact game that Microsoft was trying 15, 20 years ago, and by becoming the sugar company. So they can become the platform company in effect, so that everybody will use their product to make Dell sweeter, or make HP sweeter by using Windows. These days they have a choice called Splenda. It's not sugar. But I can't believe it's not sugar. So that was about complementer, and to help GE Capital understand the need for Emirates to get some financing terms on time whenever they want to buy a set of planes from you. You need to enable GE to operate together with you to help Emirates and other airlines, Alaska Airlines, get what you want, get what they want, so that they can get better terms. And you need some software to help you do that, to help your internal teams cooperate with your complementors to make it happen. And then internally, You need a whole boatload of software internally to do your internal stuff. Like you deal with this already all day long, to manage your employees, to manage your legal compliance, local regulations, a ton of regulations in your industry. You name it, you have some regulation corresponding to something, some law. Do this, do that, require this, check boxes, fill these forms. All of this has to be documented properly and done it right. And that requires more software, more IT, essentially. So these are the sources from where you should think about what types of software are needed at the end to fulfill the need for your customer, which is the red bubble on top. And thinking in that framework helps you understand what drives businesses in terms of putting IT infrastructure in place. And the reason I really discuss this to the great level of detail that I have is to tell you one thing, which is, if it does not fit in this picture, do not implement. If there is something, and that is more important right now these days, is in established companies at least, people do things just because they have been doing it. And that is bad. So think again, when you're looking at a system, is this something that we need to continue using or continue having going forward? Does it fit the bigger picture of the company at all? And if that does not, cut it. If you cut it, you will be the winner. The people who cut, especially in large companies, actually sustain themselves longer term than other people who don't cut, who don't think. So what I'm really trying to drive with, the point I'm trying to drive with this chart is, when you're looking at a new application or a new software or anything that might exist for years and years together, think about how does it fit going forward in this picture, and where exactly is the fitting, and who is the beneficiary, which bubble will stand to benefit, and how does it impact the central company bubble. And if there is no correlation with anything here, then it's a clear signal that you should not do it. It doesn't make sense to do it. If it doesn't fit a business need, don't do it. Cut it. So having discussed that, the goal of this discussion was to understand business requirements for IT infrastructure in the cloud. So you understand this business perspective, which is fundamental to beginning discussing anything. So I gave you a brief, broad overview of how you think about from a cooperation perspective, which was this book that I mentioned. A very good book, by the way, and only $11. So pretty nicely written book, pretty interesting, not like The Goal. Actually readable, very nice. And it is, I think, best of 2014, so it's nice. I might have it in my garage. If you're interested, I can give you, I think I still have it. This book is still there. So that was that discussion. Now let's switch topics to another one. By the way, I have videos of me talking about these things already here in the same site that I'm looking at, which you should see. And so the way to get to that is like this. You go to the site here, which is called library.cloudgenie.us. Check. The name of this site is library.cloudgenius. And in there is this tab called architecture. Click here. So the cloud architecture tab has several links here. And I just finished discussing number 2.
So this isn't online Cloud Genius, it is?
No,
No, it's not.
it is.
You sent me this stuff before, so I got it.
The link is slightly different.
As they all are.
library dot. And in there, you go to the cloud architecture. Context of cloud computing. Yeah, the videos are a little old, I think maybe 2 or 3 years old, so I might have older examples from there, but they're still useful in some fashion. So you reach this page by going to this site, http:// and then click on this tab. Got that, Chuck?
Yep.
And so here, there's this video, which, fairly long. I should not be recording that long videos. I think it's like 19-20 minutes long. So it gets boring. So I'm not playing that video here, but you can watch it on your own. We just discussed this section, which is business requirements of cloud computing. And by the way, there is a typo in the video. In the video, it says complementors. That doesn't look good, even though it means good. That the video is wrong. The word is complementor. The slide is correct. The slide at the bottom. The bottom of the video page is the link to the slide, which has PDF that you can download if you like. How long is this video? 20 minutes. No.
Is this person tonight, is it going to be here in person or here?
Sorry, which?
The mean, the guy that's.
The mean stock in person right here at 7. And it'll be a different video. I'll break this recording and start a new recording.
We'll start. Okay.
I will record.
Okay.
And if you are here, please remind me.
I can get it right from somebody else. That's all right. I can do it on there. Yeah, I got other things to do.
If you need a ride to be dropped off, I can drop you off after the thing finishes. If you just need a ride, I can drop you off, no problem.
No, that's not. Yeah. An option for you.
Okay.
So where did you, I'm at the spot where you were, the architecture, cloud architecture, where is this one now?
So I can point you how to go. I'll show you how to go there. You have to go to this site,
Okay.
and then
Yep, I'm there.
open it in a new tab. Click on the architecture tab, which is this button,
Yep.
and then the links are here. So this is the broad sequence of flow that we will follow as we drive the next 8 sessions.
This is the whole class.
Yeah, the next 8 sessions.
Syllabus.
Yeah.
I've got linked as the syllabus in the notes.
And so
I didn't not need the notes.
what we intend to do is I'll maybe leave the videos for you to watch later, and I'll skip some of this and jump to the next one, which is to help you understand this aspect of, and I may have briefly discussed this before, but this concept of scaling, and you may remember that like this. The word scaling, that I think I described it in 2 parts, which was this, whether you scale in versus out, scale up versus down. Do you remember that?
Okay.
So do you recall the difference in these 2 phrases?
Yeah, one is just.
So I'll give you an example.
Horizontal.
Right, right. Yeah, pretty much. So if I, let's say in 2001, I used to work for, actually year 2000, I used to work for Sun Microsystems. And Sun Microsystems, Sun W was the ticker symbol. They used to make a really big computer, really big, like bigger than a refrigerator size computer. and it used to cost maybe $100,000 at those times. It's a very high-end machine, Sun workstations and Sun machines, and that's a big iron machine. They used to be called the big iron servers on the back end on those days. It was very hard to build .com websites and scale using those big boxes. And so when you scale from a small computer to a big computer like this concept of scaling is called scaling up.
Yep.
When you're physically making the box itself become bigger. So for example, if you have one CPU and 4 GB RAM and 50 GB hard disk, and then you actually, there is a very good example already that I forgot to describe. I should pull it up. DigitalOcean has it already for me to use it, ready. So I'll go there and show you the pricing and create Droplet, and you will see it here. Yeah, so these are examples of scaling up.
Bigger machine.
Yep, just go to a bigger box. And so from a cheap small machine to a slightly bigger to even bigger and bigger and bigger and biggest available at DO. This is what scaling up is going to be.
So the difference with trying to handle increased capacity on your server by going to the next bigger server, the next bigger server, the next bigger server as it grows, versus adding another small. Yeah.
So look at the pricing here, and the key thing to remember is scaling up can be expensive compared to scaling out. And the reason is you can use probably 4 or 5 of these $5 servers and do a much better job than maybe these.
And you call that scaling out versus across, okay.
Yeah, the word I prefer to use is this,
Scaling
out. Or you can call it across or horizontal. That's also a good word. So I'll repeat that. The idea is to use a $5 server and then switch over to make it become a $40 server. That is called scaling up. And when you go from a $40 server down to a $5 server, that is called scaling down. That is simple. That idea is simple. The other way of scaling is to actually go from one $5 box up to 2 $5 boxes is called scaling out or horizontal or across, whatever name you like. But the idea is you're scaling out like this. And you're scaling back in when you reduce from this down to. So that is called scaling in, or rather back in. You're scaling back in as opposed to out. It is also horizontal and it is also across, but it is shrinkage. You're scaling down as in as opposed to down. So
it's easier too to scale in versus scale down.
Yes, you're right. But scaling out needs certain application requirements to be met for scaling out to succeed. And I will go into that next. Let me finish one quick idea in terms of my drawings. are kind of misleading. This arrow should not be going up or down. So I should draw them differently. I should say, this is how I should draw it, as opposed to the up or down arrows. The arrows can be confusing. So this was the scaling out part, and you can call it horizontal, or you can call it across. But the key word is we are growing. It's like a growing family. Like I grow like this, my son grows like this. That's how you should remember. So this is my style of growing. The other style in the same family is shrinking. That I hope will happen soon when I start to exercise. Is this. It's scaling back in. It is still horizontal, it is still across, but you got the point. Now some questions for you, and these are quiz questions. The question is, if you have an application that runs on this box, and it's a $5 box, can you just arbitrarily take it and put it in another $5 box and assume that it will work together to the user?
No.
No,
So what is needed? Like what is needed to make the user happy? Like,
load balance.
of course, you need a load balancer, no doubt. So I will put a load balancer here. So ELB. Okay, there we go.
not only that, I mean, the whole application has to be built for, I forgot the word, distributed.
Yes, yes. The exact word I would like you to use is called stateless. So when you don't store state in the box, then you can scale out unlimited, because your state is outside the box, somewhere else. So what is state? State of the user, state of the app, state of the database, state of the union. I'm just kidding. The idea is whatever that state is. So for example, you have this drive doc. So let's open a Google Doc. We create a Google Doc here. Click document. And there. So I'm typing something here, right? And imagine that my laptop gets stolen suddenly, like disappears from here. What will happen to my document?
Remains as well.
Save your password.
So
Remains in the folder.
remains in this exact location wherever it is with whatever name I have. So say, let's say I have renamed it my awesome document. So that's the name of the file I have and all that good stuff. And now suddenly this laptop gets dropped in the ocean in Pacific, and so it's gone. Now, where is my state preserved? It was connected before it was dropped in the ocean. It was all connected to the internet and all that good stuff. I'm on the boat and in a cruise ship with internet access, and I'm typing this beautiful poetry, and then suddenly this laptop is dropped in the ocean. Where is my state? What happens to my state? That's the question.
You were saying it was on the internet while you were communicating?
Yes. It was on the internet and all was good and everything is nice.
Yeah.
And then something happened and the laptop is boom in the
Well,
water.
that's
It's
okay.
gone. I cannot get to it now.
It's on the net, but your laptop
No,
is
the
gone.
laptop is gone, and once it goes in the water, the net is also gone. Right? So, yeah. So everything is gone.
Fish food, there you go.
Yeah. Fish food gone.
Yeah.
Yeah. Fish are eating apple. Yeah, whatever. Now what? Now where is my state and what happens to the laptop? I mean, assume that I have enough money to buy another laptop and I get another laptop, but
So hopefully the state of the document is saved in totality on your wiki, wherever it was, you did a save before you.
I did not save. Actually, I did not. There's no save button here, by the way. If you did not notice,
Oh, yeah.
there is no save button. Let's see. Do we have a save button here? File? No. There is no save button.
Well, if it has an amount of, well, whatever, depending on the design of the application.
So I'm talking about this application. I'm talking about Google Docs, and there is no save button.
Well, then it's,
Just save in real time.
I mean, I'm guessing Google Docs stores it at Google.
Yes, it does.
Okay.
Yeah.
Yes, it
So
does.
it's there, it's
Yeah,
there.
yes, it does. So let's see this other
So it's
example.
continuously writing.
Yes.
Depends
Yeah.
on how, when you get, when it actually.
So let's see another example. Right. Let's see.
I'm hoping that last keystroke
Yeah,
got
no,
to
maybe.
Google.
Right. That one was the important.
Yeah.
Yeah.
Another example here. This is the Pages application, right? And so I am doing the same thing, typing some beautiful poetry here,
Yeah, that's all.
and you think it is local?
I thought so.
No, it's not.
No.
And so they have also managed to do the same thing in
So what
iCloud.
is this now?
Pages. There is no save button apparently. Oh, there is.
Yeah.
Huh. Okay. Yeah, they were going to remove it at some point. I don't use it, but the concept is that the state of the user is the state of work that person is doing.
Right.
And so if you keep that state separate from the box,
Yeah.
you can afford to throw the box away and get a different box.
Sounds expensive.
Yes. If the box is $5, probably it is not that expensive. So we're talking about $5 boxes. You're talking about these types of boxes.
So saving the state outside the box sounds expensive.
Yes, but you can. And if you accomplish that, then you can, use a $5 box, throw it away, get another box, throw it away again.
So the state of the user is saved. You have the $5 box that the user portals through, but that information is saved into like Google Drive.
Something else, somewhere else,
Something
somewhere
like
else, right? So as long as you manage to isolate and separate your code and your database and your state of the user and state of the application and keep it separate from the box, you can scale out, no problem. And so let's examine an example as to what would constitute state separation. So I'll begin with our favorite example that we have been using all along, which is this WordPress application. And you've seen this application runs on a LAMP stack. So you have Linux there, which is an OS. There's no state as such. It's an operating system. You can, get another box with the same OS again, at a moment's notice with DigitalOcean, and that'll give you a box. Apache is a server. All it does is shows you what the backend needs to show you, and that's what WordPress will show you when you see it. PHP is the language that is used to build out the application itself. Apache is the web server, but the state is actually stored here.
Let's see.
This does not have much state info. There's no state information here. The state information is right here.
About memory.
Yes, with some in-flight memory, the last keystroke and all those things. You have to worry about that part also, if that is important enough for the user. Yes. There are some other things that are also important that are not obvious in this write-up that also needs to be preserved, and that is a part of WordPress setup. And I'm not sure how many times you have set up WordPress, but let me show you an example WordPress setup that I have somewhere here. I'm going to see if I can log in there quickly. Yes. Okay. So let me go to a folder where I have WordPress installed. This is a LAMP stack ready with WordPress, and I'm going to go to that folder right now. This is a production site, so I may not be able to experiment too much, but just to show you, these are the contents of the WordPress expanded application folder. So this is when you expand the WordPress zip file, this is what you see. And what is not a part of the stock WordPress package that you download from WordPress is this section. This section is called WP content. And this section is unique to the blog, to the site. This contains the content. In addition to that, there is a database that is running somewhere. So the MySQL version that is running here will have a database corresponding to what this live production site expects. So this site, this is the site you're looking at, the database actually looking at this site. And all the pictures that you have here, these guys, and more pictures, these guys, and this picture, they're all stored somewhere. And that location is specific to this particular WordPress deployment. And they are a part of the WP content folder in this deployment, which is specific to this box. So any box that you will take from a DigitalOcean droplet that runs WordPress will need to have the WP content folder on every droplet updated all the time. You know what that means? That means that if you have at 4 o'clock today, as we were talking, somebody posted this post right now while I was in class with you. And this picture got posted that we are sitting in this room at the blue spot and that the car parking should be at the red spot. And by the way, this is the good place to park your car for your meetup that is at 7 o'clock. See you today.
I don't have any drones.
Drones?
Yeah.
No. But, huh? Yeah.
This is the mark. Yeah.
There's the marker. The marker comes from this app that I have. So yeah. So this is where I have parked my car, and this is where we are sitting right now. So that's how I was able to take a picture of it and post it. That this happened. Auto posting happened at 4:03 today because it was planned. So if you can go to Facebook, you can see a post about it. As I was in class, it was also planned. So we should go and see Facebook post at 4:03, 59 minutes ago, place to park your car. There we go. So it happened. Now, how does this happen is one story, but how do you make it in a scale out fashion is another part. The key to think about is to remember that this picture asset that you have here needs to get replicated to all the boxes that you will have here, not just one box. That is a key to successful scaling out. Do you get what I'm saying? So if somebody uploads a picture of that graph, the map, that parking picture, and it is interacting, that user is interacting with one of these $5 boxes, that picture needs to become visible to every other box also. And that has to be automated because the user is not supposed to be uploading the same picture to 10 different boxes scaled out. They will be interacting with one box. And other users will be looking at some other instances of your scale out application and will, or should be, after that time it is uploaded, other users should be able to see it when they visit the site automatically. It is similar to you go to Facebook and you post your family pictures and all your friends will be able to see the pictures. But Facebook doesn't have one box. They have, I don't know how many of them they have. So they have scaled out. And the idea is to make sure that your family picture that you upload becomes available to all other boxes. Now, what's the key to solve that problem? How do you actually do it? So the idea that I'm describing is you have a $5 box here. Sorry. So this box, $5. And you have a picture here you upload. But this is not the only box you have. You have like hundreds of $5 boxes sitting in your infrastructure. And the other users want to see the same picture. So this user uploaded this picture P to this box. And the other users here want to see the same picture. But this is separate box, and the picture file goes to that folder called WP content. And that content is actually on this box. So now what? Now how do we solve that problem? Huh?
You put a box that holds the content behind all.
A box containing content,
Sort of like a database,
Yeah.
you could put a database that
Yes.
those are all accessing.
right?
Parsing.
rsync. So what he's describing is a potential solution. So there is this product called RSYNC. It is a open source product, and it is a differential.
So couldn't you use Chef to go ahead and push everything out to keep the, no?
Chef doesn't run real time. It runs like every so often, 30 minutes or so. So by the time 30 minutes are elapsed, and still I don't have a picture.
Yeah.
Mm-mm.
Yeah.
Not a good idea. So people want instant gratification. Like I post my picture and people want to see it right there.
I'm
And
with you.
so, say if I go to Cabo or if I go to Puerto Vallarta, you want to see my Facebook pictures right and then and there as I do something, some activity there, right? So that instantaneous publication can happen if you're able to replicate the file system across all your nodes. So all your $5 boxes here should have the same content at any given time. WP content folder. If you recall, this folder is actually sitting in this line here. So we should be able to go in that folder WP content. Let's see. So CD WP content, and then uploads, and then 2015, and then this is what, March.
So the product rsync does all the replication and it's defined within its configuration.
Yes. And so right now, let's see the picture that I see on the website. Where is that picture?
Does rsync care about what it synchronizes? No. You just point it to it and it does it.
We use rsync.
I cannot find my own picture, but there has to be a name for it.
So who, is it open source?
Yep.
rsync?
Yeah, it was it's on Unix a long time ago.
So it's Unix feature. It's been there.
So it's 2015 3 LW Tech parking. That file has to be here somewhere. So LW Tech LMN. LW Tech parking. So there it is. So that file here that I'm talking about, LW Tech parking.jpg file, got uploaded today. March 28th is today, is it?
No.
No. Right. So this was uploaded like 28th. So it was a timed post. Timed to get posted at 14:03 today when we are in the class. But I actually uploaded it on March 28th. Not right now. Not here. You did not see me in it. But that was the upload at that time. And it is sitting here in this location since that date and became visible to the public like this at the schedule. Now the replication of this file needs to happen across all these $5 droplets. How do you make that happen? One example, one way to solve is to use a synchronization method. rsync is one implementation. And what rsync does is looks at only differences and then just pushes them over. So you can define, in fact, you can use rsync as a regular copying method also. It is built into most Unixes, and you can say rsync A, B, and it will copy A to B. And it's fairly elaborate. You can do across machines synchronization like this. So you can say rsync, take this entire folder from here on this machine and copy it, only the differences over to the other machine, and keep doing it. That's one method.
Run on a schedule or just
keep running.
checks for difference?
Keep running. Keep check for difference and run.
Yep, whenever there's a difference. sync.
So that's one method. There are other methods, and I will show you that other method also. The other method is called cluster file system. Cluster file system, heard of it?
Yeah.
And the idea is that you have multiple $5 boxes. It doesn't. $5 is just a way of describing a box. Just a small box. So you have these $5 boxes. Each one of them have their own file system called EXTFS. And so each one of them have their own slash and then var / www / your website example.com / wp content folder. And so each one of these boxes will have that folder. And our goal is to keep the folder content synchronized. We can do one by using rsync. Another method is to use a cluster file system. And a very good example of using a cluster file system is called Gluster. And Gluster is built into, I think it's another open source project. Very useful and predominantly used for this purpose is to scale. So you essentially, in fact, that's a good exercise as a homework, if not homework, as a next time classwork, is to build 2 boxes WordPress with GlusterFS on the backside, so that their file system will be using Gluster, and then we will upload a picture to one and see if the other guy can see the picture. Is that interesting? Have you done it before or something like that? Or let's do it then. If you haven't done it, let's do it. So we'll take a hands-on and insert Gluster as a file system for, take 2 $5 boxes, maybe 3. The number beyond 2 it doesn't matter. Beyond 2, it's all scale out. So it's irrelevant. But the idea would be to take LAMP stack, put it on a $5 box, and put WordPress, and put Gluster FS. And then another $5 box, another $5 box. It doesn't even matter how many you put. And then you upload a picture here. And that picture P becomes visible to you here, and here, and anywhere else. So it transparently becomes visible to all other nodes and synchronizes through a cluster file system called Gluster. So that's the next exercise. So read up on that, and let's do it in the class next time. there is a new method that hasn't been published much, and that method is called a BitTorrent sync. That is also possible to use. So if you remember me saying there is a getsync.com application available now, which synchronizes anything to anything else at the fastest amount of fastest speed available on the net, and no limit on the number of files, or size of object or size of file. There is no limit. The real limit is your hard disk and your network. So what do you have? It'll just copy the whole thing over, A to B, or A to B to C to D, and any number. And it doesn't even have to be the same user. And so graphic artists or videographers use this tool quite heavily. Well, they'll go on video shooting and prepare like 5 GB of files, video files, 10 GB files, bring them on their laptop, and they want to now quickly show it to their customer away from them. So they will use this software, and as soon as they bring their 5 GB files, video files, drop them in the folder, it synchronizes there to the customer site, and customer able to view it, as opposed to shipping a DVD to them. It's a very, very efficient way of synchronizing. So that's one method. Another method of using that people are experimenting with it. I have not actually experimented, but we can use this software and do the same thing like Gluster does. I have done the Gluster part, but not the BitTorrent. This should also work. There's no reason why it should not work. It is also available. Although it is not open source, the binaries are available on Linux, and we can make this, put this to use for free. I have not tried it, but I know it will work. The idea is again simple. You want to make sure that your file system across all the nodes that you have is identical. You can do it through rsync or the Gluster or through BitTorrent or any other method you can think of or dream up. The speed of the synchronization impacts user experience. If you're physically copying, another method is to actually physically copy a file from here and put it on every node. When you're manually doing it, there's a lag involved, and users may perceive that the gratification is not instantaneous.
Potential of error as well.
Yeah, potential of errors, all these things exist. So that's why it is better to automate and make it happen by itself. So your nodes, you have, these nodes that you have in scale-out architecture. Let's say another user comes in and puts in a picture of, say, this guy puts a picture of P1, and this guy comes in and puts a picture P2 up. You want everybody should be able to download P2, and everybody should also be able to download P1. And that synchronization can happen only if you have a method on the back end. So we will try this second step, which is the second alternative, which is Gluster FS next time. We used our sync, or we can use BitTorrent sync, or we can use the boring old manual method. Which is not really a good one. So we'll try this one next time. So you got the part I described was about synchronizing file systems. There are other parts of the state that needs to get preserved, meaning if a new user comes along, they create a new user account, or they log in or they log out, they create other users, or they create other types of database structures or database entries in the database. Those things will automatically fall into the MySQL database in this example that we have, which means that we cannot have, I think I saw somebody who's probably looking for a meetup. I don't know why. Is it 7 o'clock already or what?
6.
Yeah, it is 6. So if that happens, I'm sorry, but we'll just tell them that, wait, it starts at 7, not right now.
There you go.
So if it happens, people might just walk in. I'm just telling you. They think it's a meetup, so they'll just show up, but it starts at 7. So we'll tell them that. Because I saw somebody looking for it. So in fact, there is a sign outside that says that we have moved to another room. I should remove that sign in the other room.
It's amazing how many pieces of software are open source. The bits and pieces of,
Everything is available. I mean, it's
Yeah.
absolutely everything you can think of is available.
yeah, and just knowing that it's available,
And
just
just
assume it's available and we'll find it.
Yes.
Turn on the
Pretty much
AC.
like that, yeah.
Is the AC on?
I don't know. I think this
Might
kind
be
of
the one
cold.
who's cold.
But it's okay cold. It's not too cold for me.
I'm forced to dress
So if there's a place to, I think, adjust there somewhere, maybe. Is that an AC button?
We'll see. It never seemed to really work. It
You
just there
think
for
we
show.
should?
Yeah. Social gratification.
Yeah, maybe it is only 2 people
in the building.
Yeah.
That's what we call it.
Oh, that's it, yeah.
Yeah, we are only a few people, right? The whole
Yeah.
building is, so it's like all the force.
Uh-oh. He's looking for something.
I'm gonna be right back.
So the other parts that are containing user state is actually the database, which means if you're setting up a WordPress software on a $5 box, you need to make sure that you keep the MySQL part separate. As simple as that, meaning you're running L, A, and P here, and the M sits away on another box. This MySQL needs to sit either on a $5 box or a $50 box, or I don't know what, but needs to be separate. And you cannot put this here. Otherwise, you will not scale. Which means your scales are LAP, 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 and all these $5, $10 boxes. And then you can comfortably scale because your database connections all go to a MySQL box. And that box doesn't need to be a $5 small box. It can be a $50 box to service all these guys, or it doesn't even need to be a box. Instead, you use a database as a service and pay somebody money so that they can give you the service and let them worry about how they want to scale. That's another option. So the idea would become that you put your $5 boxes with worry about LAP, not M, and scale them out, and all of them connect to a DAS. And give me an example of a DAS that you have heard me describe or you already know that runs MySQL. What would that be? A very good DAS available in the cloud. You heard me describe it. Example. An example. What is an example? EXAMPLE. What would be a good example of a database as a service available for you?
AWS provide that,
Yeah.
and doesn't, was it Heroku?
Yes.
We went out to?
Yes.
Yeah.
Yes. Yes. So the exact names are when we use Heroku, the database we used was not MySQL, but it was PostgreSQL.
Yeah.
And they have a service that gives you access to PostgreSQL as a service, PaaS. And the same company also provides you with a MySQL service.
Apparently Oracle also has.
Yes, everybody has it. They just
Yeah.
so the most well-known example in the Amazon Web Services is
Right.
called Relational Database Service.
Yeah.
And this service is here.
So both of those don't provide a Mongo
Correct.
JavaScript database as a service.
You're right. You're right. These are relational, right?
Yeah. It's almost like I'm paying attention.
Yes, yes, you are.
Yeah.
And so here, if you look at RDS, so I'm going to expand and make it bigger.
Yeah.
And so if you look at the RDS services, the database services, this one gives you access to,
Yeah.
let's see what they give you.
Other services, well, I'm sure there are. I just assume there is. Mongo is a database as a choice.
Not in this, but another one has this choice. MongoDB, MongoLab has a choice. MongoLab is one choice. And so they will give you Mongo database as a service.
Yeah.
And when you sign up,
That's
You can-
their database.
you can choose which cloud you want to use. And so you can choose that I want to get a database in my, let's see, create a database, create new. You can create a new database and it'll ask you, where do you want to create? Meaning you want to create with,
Look at that.
you want to have your machines in Amazon or Google Cloud or Joint Cloud or Rackspace Cloud or Windows Azure. Where do you want it? And they will provide you a database as a service in the cloud you choose. So you can then further select that I want to use the region, the Azure regions. Okay, fine. So Google Cloud, I want to say Google
So
Central.
they're not providing the cloud, they're providing the Mongo instantiation at those other, got it.
Yep.
Got it,
And
got it.
they'll charge you nicely. Like, you get a tiny little box free. But the more you need some storage for real, 120 GB SSD, they'll charge you $550 per month. If you're talking serious business. Let's switch to Amazon. If you're choosing Amazon Cloud and you are in the Oregon region and you want a MongoLab box available, you can get the smallest, cheapest for $180. The plan comes with 2 data nodes plus 1 arbiter node. And that's how you would get Mongo deployed.
So
for
the
you.
licensing, you said per month, goes back to Mongo Lab.
Yes.
Yeah.
Yes. And this is the pricing that they have. If you can free box 500 MB database for free. But if you want a bigger box, you get $15 per GB. There are many other providers like Mongo in the cloud, Mongo as a service. Let's see who else does that. So we have Rackspace doing it. We have Compose, another good company that does that, is this. So production ready, cloud hosted, whatever you want. You want Rethink DB, you want Redis database, you want PostgreSQL database, you want Mongo database, you want Elasticsearch,
Oracle.
Rethink,
No,
huh?
Oracle SQL Server.
Yes. So I think I don't think they'll give you Oracle.
So the whole main stack is open source, is.
Yeah, all the components are, yes, indeed. It is open
Okay.
source.
So Mongo from there, you're paying for their support and distribution. is what you're paying for.
Yes.
Um,
So most open source users will create services and sell services so that it makes your life easy.
Yeah.
They don't charge you for the software. The software is open source.
Yeah.
You can do the whole thing yourself and pay. Let's say you get this $40 box. Maybe get 2 of them. Spend $80 a month and get a decent Mongo deployment yourself. And all it takes is to run this script I have. I mean, nothing much. I have a script here. You go there and you run it. It's very, very small script. Prepare. Where is the script here?
You've got a
Mongo.
script that you use cluster.fs to replicate everywhere.
Okay.
So these guys could be using Amazon.
Yeah, you can use any. They give you choice of cloud. Where do you want to go sit?
Yeah.
And so they will go help you in your cloud. And so
That's a
here-
different model. They don't offer the hardware or
Right.
the service, but the software distributed somewhere else.
And so here is a script that you will run on a box. It's a very small 58 line, 62 line script. And you run it, it will create a Mongo service for you on the box. It's Ansible script where you can write a chef script. There is a cookbook available for Mongo. You run that cookbook on the box that you select here, and you have a Mongo server ready, up and running.
Yeah.
The problem is you have to maintain it. And so you either pay time or pay money. What do you like is what you keep.
So if the Mongo place that you ended up pointing to AWS, you have to give them credentials, they create the credentials?
I'll show it to you right now. Here. So let's go. Let's do that. So Mongo. I want to get Mongo database. Fine. I'll say I'm going to pay you $15. Click. Click. And it's going to ask me, which cloud do you want to go live in? So I'm going to say, I want to go Amazon cloud. Fine. You want a single node or a replica cluster set? You say, a single node is good. Fine, single node. And you want in what region? You can select your region you like. So you want Amazon cloud, select your region, single node or replica. And then you say, I want to get a free sandbox just to understand. So we'll go take that. You can select MongoDB version. There's only one choice, 2.6. And then you can get to define your name. So I get to give a name. We'll call it the Cloud Genius test. Cladu. Okay, Cladu is the name. Sorry.
Yeah,
Yeah.
it's like
Yes.
Claudio Necto Barabbas, what was that movie? You remember? No? Okay.
So the price that we know, $15 a month, $0 a month, the name is Cladu, and we'll create a new Mongo deployment. So it will actually go identify a T2 micro box and deploy Mongo on that and give us credentials right now. And then we can go to our chosen provider, which is Amazon, go to our chosen region, which is East 1, and then look at our Cladu. This is the Cladu database, is up and running. It is in the AWS East 1 cloud. Good to know. Let us see what else we have.
So Cloud Genius has been there before.
Yeah. So yeah, that's why I created a Cladu this time. And here I'm going to go in the Cladu database itself. And there is my login detail. To connect to the connect using the shell, you type in this command. And to connect using a driver using the standard URI, you type in this command. And here we have the database user is required to connect to this database. So click here to create a new one, create one. We'll create a name. Username is called Matt. Database password is BURRELL, BURRELL, and say create. And so we have a Matt user. and it's not read-only.
Is
Which
that
is-
the first time that a password is applied, or does it have a pass?
First and only time that you have to provide a user for the database you created in the cloud for you as a service. And this service is sitting in your chosen cloud provider in the region you chose and the size you chose and the money you agreed to pay. And now you have a user, which is good. And now what we can do is, we know the user and the database and the password. We'll take that command that they have given us already, which is this shell command, and bring it here. And our username is Matt. Our password is BURRELL. And so our URL is actually here. It is ds059471.mongolab.com /port number /Cladu, the name of the database,
Yeah.
and then user and password. So we'll take that detail, go to a terminal, and see what happens. Do we have Mongo here? Yes, we do. So we'll clean it and say connect to my cloud database. Now the challenge I have is I don't know if that port is open for going outwards, but we'll give it a shot. And there we got connected to the cloud database.
Very
Right.
cool.
So it's very simple and very, very handy. If you pay $15 a month, you get nice, decent database, Mongo ready and running, and you don't have to worry about it.
That's good service.
So right now I'm using a free one, but you get the point.
So SQL commands, you said earlier, it said no SQL, it said not only SQL. So you could do a select star from, and it would work.
Yeah.
It's not a superset, it's a subset.
It is JavaScript.
Yeah, when you said not only SQL, I thought it was incorporating plus a whole bunch more.
Yes. You have to add more software to make use of the SQL syntax. But by native design, Mongo will work exclusively with JavaScript. If you know JavaScript, you can do Mongo.
Got it.
If you want to use the SQL query language, SQL language, you have to add more software. It will work. But strictly JavaScript is what Mongo is.
I like that, JavaScript within Mongo, JavaScript in the
Everywhere.
JavaScript environment, everywhere.
JavaScript
Yeah.
front, back, all the way to database. It's
Yeah.
much easier. If you know one language,
Yeah.
you can do it all.
Yeah, very
The
smart.
problem is that one language itself is so horrible.
Yeah, I'm gonna change my comments here.
So I'm going to delete that database. It's unnecessary. So I'm going to get rid of that Cladu database, delete and go. So it'll be gone. And now our terminal should be broken by now. Still working. It's not deleted yet, probably. So yeah, I just exited. But the point being that you have these scalable boxes. You want to make sure that your database is separate.
Yeah.
Your file system is synchronized. And then you can scale out. Otherwise, you cannot. You get that? So you get to scale if you use MySQL as a service from, say, RDS, and then you put your T2 micro, another T2 micro, one more T2 micro, another T2 micro. You can keep scaling out all day long, and it'll be fine, as long as you put your database separate. And all of them.
When you talk about state aware, and when you were talking about the LAMP stack in comparison to the mean stack, the way the JavaScript environment has been engineered, does it, in the command sequence when you're performing the function, does it automatically know that it needs to be saving the state? Or is that something that you program in your JavaScript?
Application writer needs to program it to save it.
Okay.
Otherwise, it will not save by
That's-
itself.
Okay. So you're giving architectural best practices
Yes,
to make sure that the state is separated from the user.
yes.
You do the same thing in the lab stack. It's just good coding practice.
Yeah. Yeah.
Okay?
So in Mean application, in Google Docs or in Apple iCloud or other applications that are being developed, the idea is to keep your state away in the cloud as much as you can, so as to minimize the user frustration of restoring devices.
Yeah.
In fact, you can Apple claims that if you lose an iPhone, that they'll give you a different iPhone and you log in with the iCloud account and all your things will come back. And I think most of it is true.
So if you exceeded your 5 gig storage quota.
Yes. Yeah. The assumption is that you were actually an iCloud subscriber, which I have not seen anybody yet. I don't know who subscribes to iCloud for exorbitant pricing, but
They just lowered it.
yeah, but still, it is not zero.
How much is it?
Yeah, it's $3.99 for 2 gig. Or 200 gig.
Oh, $6.99 for a terabyte. That's-
This $0 for Cloud Genius storage.
Yeah.
I mean, beat that.
For unlimited. AWS just went unlimited.
Yeah, but not
For
zero.
for $39 a year.
It's still very expensive.
$39 a year.
Still very expensive.
That's like less than $4 a month.
Yeah, whatever. Free is free. I
You
mean,
gotta do that one Starbucks a month.
I don't even drink coffee.
Chai tea. You know, one less chai tea.
I just had coffee, so tea is not interesting to me, apparently. Yeah. So the point that I really want to drive is keep your state separate from the box, and then you can scale out. In case of scaling up, these questions do not apply, because what you're doing is actually keeping that only box. It's the same box, it's just a bigger box now, right? So you don't have to worry about the things that keeping state separation, because all you're doing is making the box bigger with the same hard disk. And so it just becomes big. So scales up. Scaling up can be done only up to a limit. And the limit is here. Not beyond that. You cannot go beyond. It doesn't allow you to do beyond that. 600. We cannot take more money than $640 per month. I don't know. Maybe there are companies that do. And so, in fact, if you're new to DigitalOcean, they would not even let you create these boxes. They're probably hidden. These are probably hidden for you if you're new.
The Mondo box.
Is it called the Mondo? They have a new region. Huh.
Wow.
And another thing you just pointed out, they have a new DNS service, like Route 53, which is nice. So yeah, good things.
Use Chef to.
And you can programmatically add a domain.
But yeah, so that you can, instead of having to manually go and point a name to your IP address,
Yeah.
it can happen as part of your script.
You just add a name and IP address and droplet, and boom,
Oh, yeah.
select a droplet. That'll be awesome. So scaling up has a limit. Scaling out does not. You got that. You can keep doing this $5 boxes until, what's the phrase in Texas? Until cows come home. Yeah, cows come home. And so you can keep doing that until cows come home, and then you can scale out to the extent you want. Having said, think we should close the door. I get distracted, really distracted.
You want me to
And
do
I'll
it?
get, yeah, go ahead, please. So this was the slide that I think I think it's item number 4 that I just discussed, and you can go over that in number 4 in the list. Chuck,
Okay.
number 4 in this list is what I just went through.
It's $59.99 a year. The unlimited everything, Amazon.
They discount, I think,
First-
3 months. 2 or 3 months.
Oh,
For
yeah.
Prime discount? For Prime?
You get the unlimited storage if you have Prime. You get unlimited storage for free.
What, you get what?
Prime,
If you have Prime, then what?
you get the unlimited storage for free.
Only for photos? Or?
I'm not sure. Maybe
Huh.
it's just the photo.
I have Prime.
More storage.
I just saw something on it.
I don't know what will I store there.
Yeah.
Where did I put that?
That's the problem. I don't necessarily need more storage, they need more memory of where I actually put it. Just leave it on everything about everybody, or nothing about. There you go, yeah.
You were a philosopher.
It knows.
My buddy Jean Paul Kearney.
Existentialism.
So before we meet the next time, I would like you to review these items. They have like 20-minute videos, and I do not want to play them here. So I would rather have you watch them on your own time by the next time we meet. So at least up to these number 6. The 1 through 6 will be a good one for you to review. There are videos 20-minute long. Sorry, I should have made them sound smaller. They're way too long sometimes, and I can go on, and I don't seem to stop. You can. The good thing about videos is that you can forward and mute if you don't like me.
Sometimes multitask.
Yes. So I know some videos can be really boring, and I have listened to those videos many times, and I find them quite boring. But up to you. They have some good information. So watch them.
Yeah, cool.
Thank you. I'm not forcing them on you, but if you like,
Which ones again?
1 through 6.
Do you like 1 through 12?
Oh. And there is 12.
Oh, baby.
You get extra credit for reviewing item number 12
Yeah, really.
and discussing the video.
So the next thing I would like to ask you is that Amazon has one of the best illustrative examples of a variety of cloud architecture for a variety of different types of use cases. And they have a full website dedicated for that. And that website is this. And it is called the AWS architecture website. This website, aws.amazon.com/architecture, this site has a ton of examples after examples of best practices available in the industry, and they have laid it out in form of reference architecture. And these are available here, and that you should review. There are. In fact, I would like you to I suggest that each one of you take up an example of your interest and pick one of these and study it on your own and come and describe it to us, all of us, that how would you make sense out of it. And I'll begin with one simple one right
Show
now.
the URL real quick again.
Yes.
Just I want to AWS, Amazon.com. There you go. Thank you.
So the idea would be to understand. So they have very nicely done charts like this, for example, for every use case. And so if you look at the main website, the architectural site, they have these examples given out here, which they refer to as Amazon reference architecture diagrams. And for web application hosting is this segment. Content and media serving, this segment. Batch processing, fault tolerance and high availability, large scale data processing and huge data sets, ad serving. Like how would you make Bing ad platform, or how would you make Google AdSense ad platform, something like that. Disaster recovery for local applications, file synchronization,
Very cool.
media sharing, online games. So if you build your own Rocket games or build your own, what was the other game? Riot games. Log analysis, you collect logs, and Expedia does this all the time, where they have logs of people visiting their site and abandoning their site for looking for a deal from another carrier, another provider of a ticket. So the abandonment logs are key to analyze user behavior, and they apply these concepts described here in log analysis, for example. Financial services grid computing, how banks operate their computers, is structured out here. E-commerce websites in two parts: the checkout pipeline and the front end, and the marketing and recommendations engine. So 3 parts.
Can you pick a pattern? I'd like this. I didn't see that on the website.
Now, there is no pattern. The idea here is that for every type of use case application, they have defined what would constitute a best practice if you would deploy this on the Amazon cloud.
I see. So
there is no pattern.
You would have to construct it with.
Yes. But they'll give you ample detail, and I'll give you an example to help you understand. These are only 1-sheet pages, but very well contained, very well articulated in terms of what they are trying to accomplish. So if you click on any of these pictures, so let's click one of them. And if you look at this picture, it is just 1 sheet, 1 page. That's it. Not too much to read, but quite a bit to consume and understand. And that's the exercise I would like to have you take on one of these items and study them in depth. Come back here and discuss with the class as to what that means and how would that apply to a business that relates to, in this case, web application hosting. Or in another case, a bank. This is probably not a bank. Where is the bank example? Here. How would a bank use it? So financial services grid computing. How will a bank use Amazon as an example?
Well, good job.
And then more examples here about log analysis. So the example of people collecting logs. And by the way, these guys, I'm not sure if you met them the last time for a meetup. They had come here. these guys are doing log analysis. This gentleman and this gentleman, they are doing log analysis for Expedia. And this is exactly what they do, is to analyze logs of people visiting Expedia.com. I just visited that site and I look for a ticket, and if I abandon it, every activity that I'm doing on this site is getting logged on some server there. And they are the people who are actually studying these logs collected by users visiting Expedia.com and 40 different web applications among all these sites that they have. So they have hotel partners and cruise partners. I don't know what else they have, but tons and tons of sites. People worldwide visit them, and they analyze these logs to make sense of what makes a good behavior. A good behavior of a user from their perspective is somebody who visits the site, looks at a ticket, and buys it. That's the behavior they want. In fact, ideally, what they want is every single visitor converts into a buyer and pays a good price, whatever they ask. That's the behavior they want users to be, but they will not be able to understand unless they analyze the logs that are coming in from the users that visit them. And so these guys actually focus on log analysis. They are analysts for Expedia, focusing on collecting all the logs that they have in a big, I think it's now 4 petabyte Hadoop cluster that this gentleman, this guy, he manages it. He's a director of IT data warehouse at Expedia. Not this guy, this guy. And he is managing this cluster, Hadoop cluster in Expedia, doing log analysis. They're not on Amazon, but this is a representation of the architecture. So how would Expedia do it? Would be an example. And what I intend to do is walk you through each one of these cases from a user's perspective on how an application is laid out and constructed on, in this example, the Amazon Web Services. But AWS here is just an example. You can do the same thing in anywhere else, as long as you have the building blocks to make it. For example, if you do not have a ready-made Hadoop solution in DigitalOcean, then you have to create a Hadoop solution on your own. But in Amazon, you already do. You can use EMR. They have a service ready for you. You can use that service. If not, you build your own Hadoop cluster using barebone boxes, $5 boxes or $40 boxes, whatever you have. And you build your own infrastructure based on what is available on that cloud. But if you take a step back, this is not about Amazon, but about understanding usage of a given type. In this context, web log analysis, and how would that be applicable to a given problem of understanding user behavior and collecting all that data in this big Hadoop cluster, which has accumulated 4 petabytes and growing every day. The people are clicking on Expedia.com, and all those clicks, all the activity, like what transactions happen, what transactions do not happen, what credit cards number go through, what credit card numbers do not go through, who are the people who are trying to steal other people's information, who are the people who are actually actively using to search for tickets and fares and prices and hotels and taxis and rental cars and whatever you have, and compare that with 40 different properties that Expedia has, and making sense out of it in terms of, if, for example, you want to buy a ticket to Hawaii and you go to Expedia.com, you see that there is a ticket available for $2,000, and you go talk to your wife and she says, no, it is too expensive. So you come back to the browser and you try to close the browser window. By that time, Expedia has done an analysis of your behavior and compare that with other people trying to buy the same ticket for the same destination for the same time, and see what the market price is going at that moment compared with other competitors' activity. And if they find that at the end of the analysis, which is happening, by the way, in real time, so this is not a batch processing, it's real-time log analytics that is happening. And if they find that something can be done in form of giving you an incentive to not go away from the browser window by offering you a $200 coupon, they will give you a pop-up. If you close the window and walk away, pop-up will come. Hey, $200, take it.
You're in Facebook.
Yep, everywhere. And so this is very well orchestrated, almost like a used car salesperson, if you think about it, which is, you know, I'm maybe used car salesperson. I know, I do that all the time. If you did not know, that's a very valid trick. You actively, when you want to buy something, actively walk away. And I have done this many times. Actively walk away from a site you're wanting to buy, and here comes a discount. And I'll show you a real live example right now.
That's happened to me a few times.
I do this deliberately. I mean, so deliberately that you would not believe. Yeah, you would not believe it is so deliberate. And where is that? What's the name of the company? Before you.
Snap error log.
Yeah, here. So click and read that email. Derek Staples. So from this company, I actively walked away, and see what they say right now. I understand that you recently canceled your subscription. We would like to offer you a following $100 discount on your monthly subscription cost permanently.
Wow.
I said, wow, exactly when I read that, because I was expecting this.
Well, that's a good way to buy loyalty there.
I know. I was totally expecting this. So I deliberately canceled this before I go to vacation.
Wow.
And this is very unnatural. It doesn't strike anybody's minds unless you think like that. I think like this. I know what people will do when I behave in a certain fashion. So I deliberately go to the other extreme of walking away from the browser window. Click the cross button and say, no, I don't want it. And there comes a pop-up. $100 per month permanently? Huh, that's a 50% discount. It's a $12 service. Nice deal. I might take it. I'll study that. But it's an offer. So I have it sitting. And it's a very, very interesting offer. So you saw this. One example live. This was probably done by a human being. But you can see the same thing happen in log analytics with any other service provider that sells you services. Now, if you know these things, you can play. And flip the game on the other side. Now you pretend that you are the company, and you want to actually give these kind of offers to people that makes business sense. You just don't want to give away money like that. Like giving away discount is not a good thing unless you're giving it for a valid reason. So you have to have a reason. For example, there is a competition that is going to take the business away. So you would rather keep the money with you instead of giving it to them. That's a good reason. Other reasons can be that you want to build loyalty or trust or some other fashion, that you want to earn business, retain them, and you want to give them as a token to keep their business. That's another reason. So there are many other business reasons that you can apply, but don't discount for the sake of discounting. Like, have you ever seen the price of an iPhone on Apple's website going below $199 for a new introduction? Never. It doesn't happen. Even on day after Thanksgiving, it doesn't happen. Like, it is still $199. They don't negotiate. And I think it's a good thing. It's very rare that companies do not negotiate and stick to their price. And that happens only if you know what your value is worth.
Yeah.
So you don't discount. And that's a great policy. But then not every business is like that. Right? So you have to discount. And you can do that very systematically and very methodically on a real-time basis. And that's one application that people have deployed in analyzing what users are doing with their application. Clickstream analysis is what they really do. is what people are clicking on 40 or different domains that they have. So Expedia.com is just one. What are the other names that I don't remember? But about Expedia, I think they have Pronto, Home Advisor, Pronto.com, Home Advisor. I'm sorry. Yeah. Egencia, Hotels.com, Veneer, Hotwire, Classic Vacations, Bloglines, CarRentals.com, City Search, Gifts.com, LendingTree, Match.com. Match.com? I don't know.
Cool.
OnlineShopping.com. So all these sites that they have and they own, they know user behavior. And so if the same user is visiting this site and that site and trying to jump and hop, they can do what is classically known as clickstream analysis. And this is the architecture you would need. Now, it happens to be sitting on the Amazon website. So all the references here are Amazon, but this discussion is not about Amazon. It is more about log analysis and how it applies to what we want to be able to do. So what I want to take this discussion next is to ask you to go home to this location, read up what you have, pick one or two of them. There are so many different, I think there are 14 or so examples. So we have more, 1, 2, 3, 4, 5, 6, 7, 8, 16 examples. Pick 2 and study them and do not superimpose. I mean, if you keep separate, keep your areas, if it's already selected, don't reselect it, and bring your discussion back in the class after what you actually study. So for example, where is that? Content and media serving. So here is an example of how you would build YouTube. And I will now describe to you this sheet. And it would become an example of what I would expect you to come back and describe to others when you do on your turn. So this is the example of content and media serving. As the name goes, it is about building YouTube. You know what YouTube is. You take a camera, you record a video, and then you give that video to some website. And that website in turn will come back and show your video to everybody else. That's the idea, right? You know YouTube. I don't need to tell you. So here in this picture, let's look at it. What's going on? You have that dude here, this dude. See, he's the end user. He's the person with the camera in hand. And that end user goes to his or her browser and looks up www.youtube.com. And that reference goes straight to Route 53 at the bottom here. And that's where it translates to a number, an IP address. And from that IP address, it knows where to go. So when the user, the first user who is going to create a YouTube content, new item, will take that item from here, log in to the website, and then upload that video to somewhere in this bucket in S3. As an example, S3 again is an example. It's a storage location where you store your video. And that's where the content gets uploaded. That's the first user coming in and uploading their website, their video, and sending it here like this, step number 1. That's the marking here, number 1. It is using simple storage service and putting that video in some bucket somewhere here. That's the first step. Now the user has uploaded their video and the video is available here in the bucket, and the user is happy and they're notified that, yes, we got your video, thank you. User goes away. Another user comes. This user has no intention to upload, they just want to watch something. So in this time, they will again go to their browser open up www.youtube.com, goes to our Route 53, looks at the IP address, goes back in here, and then this time looks up a video. This video is being served to that user, not from the bucket, but from CloudFront, which is a content delivery network. Hi, can we start at 7, sir? Thank you. We start at 7, right?
Yes.
Thank you. Sweet deal. No.
Oh.
Thanks. Thank you. Is it already 7?
There's 1 out of 35.
And so the idea here is that you take this object and, sorry?
No, I was just, you just went, no.
Yeah, it's a classroom. I cannot allow this thing.
Good.
No.
Thank you.
Amazon S3. The idea is to take that bucket item and deliver it to the user from a content delivery network, CDN. You used CDN before, have you? You have used CloudFront specifically, have you, in this class? Right, you recall? The idea is to take this item from the bucket and give it to the edge location in Singapore and in India and Bangladesh.
That's right.
So take it global. So your YouTube video becomes globally available to your users through use of CloudFront. That's what this second user is doing, is accessing CloudFront, and through that, getting the item from the bucket and getting served on his device or her device, right? That's the scenario here. In a third scenario, you have a live stream source here in this corner. And that is what I'm doing right now. I'm live streaming right now this video right now as my screen is getting broadcasted, and I am the live stream source. And this endpoint is taking this stream from my screen and sending it to some form of media server that is live streaming my content. And if you happen to open YouTube right now, you can see my screen and my mouse motion as we speak. Have you ever seen that thing before on YouTube? Right now, you can go there and see it.
Not on YouTube.
It is on YouTube also, and it is live broadcasted only to CloudGenius, and so it is restricted access. But you can see my mouse motions, and if I stop my broadcast on screen, you can see my face at the moment I speak. So live transmission happens through this live stream source, and it goes through in this example, they have chosen to describe Flash Media Server, which is the implementation available in Amazon AWS already. But the idea behind this is that you can use any kind of real-time streaming server solution that takes real-time stream of a video feed coming from your stream source, as opposed to the other story was that you have a full video already sitting here as an object in the bucket, and you take that from a CDN source and show it. In this example, it is a live stream getting broadcasted through a broadcast. Example here is Flash Media Server, which is a product from Adobe. And the encoder software is this one, which is what is available. There are other solutions also available called Wowza, another media serving solution available that you can use. And then there is another one from open source It's called Git Red 5. It has moved here. Okay. So Red 5 is a media server that you can deploy in open source, just like these guys or these guys.
GitHub.
And GitHub, yes.
Yeah,
It is on red5.github.io.
amazing.
And you can take these servers and create this box without having to pay for Adobe Flash Media Server license and use Red 5 instead, and stream your live stream through your box, through that Red 5 server to a CloudFront location again that is now transmitting a live movie as opposed to showing you a stale object in the bucket. So the third scenario, which is live streaming through CloudFront. Second scenario was a dead object. I should not be dead. It is a stored video. Stored. Yeah, it's a stored object, not a dead object. It's a stored object, but again rendered through CloudFront. And the first scenario was you take your object, you create a new object, and you upload it to S3, and you store it there. You also remember the idea of a CDN miss and a CDN hit, right? You recall that? What's a content delivery network miss and what's a content delivery? Oh, what is this? No.
This is when the content is
Not in the CDN,
close to you.
right? Not in the CDN, not in Singapore.
Far away.
You have to go to Seattle, get it. That's a miss.
But then once a miss is detected, then it gets replicated to the CDN closest to you.
Yep. So the same concepts apply again here. It's CDN, and see, start at 7. Thank you.
Okay.
And so the idea here essentially is that you build this out. Doesn't matter whether you're on EC2 cloud or another cloud, but you look at this as an illustrative example of how you would build out something for a given use case. And the focus is on understanding what that use case is. And in this example that I described to you was YouTube style video uploads and video consumption. And also real-time streaming of videos from a source out to somewhere, right? So I think we should let them in. People are getting anxious. So I'll stop the broadcast.